This is the mini lesson for 3.5 starting on page 178. We will see a lot of ties to chapter 2 with direct variation and constants. The Shoe Superstore sells name brand shoes at a price much less than most department stores. The chart hanging in the store displays the normal price of the shoes and the Shoe Superstore prices. I'm going to call this the department store price. I'm going to put a D here. And the Shoe Superstore price, I'm going to put an S. First question asks me, do the Shoe Superstore prices vary directly with the regular department store prices? Remember, when I see that, I think Superstore varies directly with the regular department store. So in order to decide if they vary directly, I need to set that ratio up. 16 over 20, and when I reduce, I get 4/5, which is 0.8, which I could also say now is 80% since we're talking percents in this chapter. But I need to check this every single time because it's asking if it varies directly. I don't know yet. So 20 over 25, that reduces to 4/5. So that's 0.8, that's 80%. 24 over 30, 6 goes into both, so I know those are all the same. 28 over 35, 7 goes into both, those are the same. 32 over 40, 8 goes in both, so far still the same. 40 over 50, 10 goes into both, and it looks like they do. So it says explain your reasoning, so I need to answer the question, do they vary directly? Yes, they vary directly. And then I'm going to say, when I explain, I got a constant, remember that word, of 4/5 or 0.8 or 80%. Okay, now here we have to discuss this a little because Alfie claims that the relationship is not directly proportional. We just said it was. She says it's not because a $20 pair of shoes is $4 cheaper. So she looked at this, you're saving $4, while a $50 pair of shoes is $10 cheaper. So do we agree or disagree? So obviously we disagree because we said it varies directly. So I am going to disagree. And the reason is, if we really look at that 0.8 or the 80%, the Superstore prices are all, they're 20% cheaper than the department store. These prices are 80%, so that means we're saving 20%. We're saving 20% every single time. So it's not the difference in the dollars, it's the percentage. Okay, here's what I want you to remember a lot from chapter 2. So it says to define variables. I'm marking my text. We had just said that D is going to equal the department store prices, and S is going to equal the Shoe Superstore prices. Now it tells me to write an equation. Remember, as soon as I see that, I'm writing down y equals kx to represent the relationship between the department store prices and Shoe Superstore. I'm going to go back to my table. Here's my x, here's my y, and any one of these three are my constant. So if I go back to this, y is s, my constant, I'm going to use, I think, 0.8, and then my x is d. So what is the constant? We found out that the constant is 4/5, or we said it's 0.8, or we said it's 80%. So if we're going to interpret the constant to this problem, we're saying the shoe superstore is 80% of the department store's prices. So here, what is the shoe superstore price for a pair of shoes that cost $28 at the department store? So I'm going to go back. I'm using that equation that we just wrote. S equals 0.8D. $28 is at the department store. So S equals 0.8 times the $28. So again, if we just grab our calculator, 0.8 times 28 at the shoe superstore, 22.4 is my answer, but I need to make sense out of that. It asks, what is the shoe superstore price? So the price would be in dollars, 22, and I would never say $22.4, make it look like money. So $22.40 at shoe superstore, and that would be if it cost $28 at the department store. I'm going to let you try to do the same thing here. Use your equation, figure out where you put the $15, and then you should be able to solve.